A fine segue, sir. Okay, we're recording, so don't give up the launch codes.
They don't know what I know. They don't know.
Hey, it's Zengineering Podcast. I'm Adam.
I'm Brian.
You were fully looking the other direction when I launched into that intro just now, to the point that I was like, is he going to get it? Is he going to get it?
I'm sharing that social
Good work.
contract document with a good friend, our friend Pat,
Good work.
our good friend Pat, who's coming up on our next who came up 6 or 7 episodes ago.
Yeah. Next episode, chronologically, for where we are now in time on a Saturday.
Hello, I'm Brian.
Welcome back to another Zengineering podcast. Thanks for listening, and special thanks as always to our backers on Patreon who throw us as little as $1 an episode to keep this going. And thanks also to the people that have rated us and reviewed us on iTunes and that talk to us in like all the places, because that helps us keep the stoke up.
That's what things are like here in Southern California. It's all about the stoke. It's great, warm and fuzzy for us every time we see a nice review come in.
No, for sure.
Even the 4-star reviews, I would imagine.
Oh, shut up, Siri.
Because we've only got 5-star
Siri just
reviews.
said you accidentally summoned me.
How did we accidentally summon Siri? I don't like that she's using those verbs.
I said yes. She said I thought so.
I don't want to be summoning Siri.
Now my question is, did the algorithm recognize that, and will it not do it next time it catches that pattern?
I hope so.
Probably no. But that was a nice interaction to make me feel like maybe it's going to learn.
I would say probably. They've got a lot of engineers up there. They've got like a whole room full of engineers at Apples, don't they? At Apples.
At Apples?
They've got bushels of apples.
So we haven't recorded in a while.
It's been a little while. Maybe a month
at this point.
That's cool. We needed a little break.
This episode, we're going to follow up the previous episode we did about space. And we'll put that one in the show notes so you can listen up if you haven't heard it before. And if you haven't, welcome, new listener, because you must have jumped on soon. If you didn't, it was only 10 episodes ago.
We've like doubled our listeners since that episode.
But
so definitely welcome to new listeners.
In that episode, we talked about we were honestly, it started from a day when we weren't sure what to talk about, and we were like, you know what, we're never not excited about space. And so we just started talking about like the idea of exploration and what we know and how we know it, and the idea of exploring and looking at the night sky and how much it's like in our genetics to care about the cycles of the earth, because without them there's no life. And so we have for so many thousands of years been paying attention to the patterns that we see up there and finding ways to explore. It's just bananas.
I always like that comment when you make it.
It's bananas.
It's just bananas. It's slippery, it's slimy, it's delicious.
Donald Duck can slip on it.
When I worked at the golf company, the manufacturing company I worked at, one of our like 2 or 3 OSHA reportable incidents one year was someone slipping on a banana peel in the parking lot.
What?
We had to report that to the federal government as an accident on site. It's a real problem. It's a real problem right now. 1 in 10,000 people will experience banana peel slippage in their life.
So space and exploration. So part 2, we decided what we were going to do is try to pick through the solar system. Last time we talked kind of about what we know about Earth and about a lot of the sort of the impulse for exploration and how we've done that exploration. But the next piece that we wanted to talk about is just the solar system. Like what we know about the planets that everybody learns about in grade school and they memorize. Isn't there like a mnemonic for the planets that that everyone
probably
learns?
There's probably a song or something.
First piece is like, what do you mean when you say solar system?
The solar system. Well, let's deconstruct that for a minute. Because I was like, oh, cool, we're doing like our planets, we're doing like the solar system, right? And then I was like, oh, cool, we'll just talk about our 8 planets. And then I was like, you know what? doesn't really have anything to do with the planets. They just happen to be hanging out there.
Yeah, it's called the solar
system. The sunny system. And
Right.
so it's called that because the sun is basically the whole thing. There's really not much else out there. We think of these big planets, we think of Earth as this big thing, but they're just like little specks. They would just get sucked up by the sun and swallowed if it could get them. And believe me, it's been trying.
The sun has been trying to swallow us. I mean, that's the whole thing. The whole solar system is essentially circling the drain. I mean, on a time scale that doesn't mean anything to us as humans, but if you imagine, that thing where you like put a coin in a ramp and then it circles and circles and circles and goes down, or like a coin wobbling and falling over. Like that's essentially the dynamic you're describing.
It's the same thing.
The solar
it's just
system.
Very, very low friction on that funnel, or virtually no friction, but with other weird things happening.
Right. Weird things, man.
There's so many weird things happening once you leave our planet.
So then tell me about the sun.
Well,
we talked about this in our very first episode. It's like mostly made of iron, right?
No, the sun is mostly made of hydrogen. It's just the most basic element. It's just the sun is basically, I like to tell people, it's just a big...
Where did I get iron from?
It's a bit
it eventually collapses to iron.
It's got iron
and then
in the
explodes,
middle.
and then we're all fucked. Okay.
Yeah. It's basically like a layer cake. And the layer cake, as it like transforms and ages, the heavier layers fall to the middle. So think about how like if you drop a penny in a wishing well, the penny drops to the bottom. That's kind of what's happening in the sun, right? It's this big ball of gas. And as it like does its thing, as it burns up and explodes and sends all this heat and radiation and particles out into the solar system, its system where we reside on planet Earth.
It's sphere of influence.
It's sphere of influence. It's heliosphere, I think is the term. And as it like ages and it converts this material, the material changes and just falls. It just falls to the middle. It's no different than like stuff falling in a bucket of water or like stuff falling out of the sky on Earth. It's just gravity pulling all this gunk together. So you got a big core of iron and other heavier materials, and then you got this big ball of gas, which is essentially what Earth is, right? Earth's just a big pile of stuff that fell in on itself. The heavy stuff's in the middle. We got a big chunk of metal in the middle. We got a bunch of rock and molten crap floating around, and then we've got air and water on top of it. We think of it as kind of like that's just the way it is, but it's just a bathtub, and stuff fell the way it's going to fall.
It's a density layer cake.
It's a DLC.
Fucking universe.
It's a DLC.
It's just a density layer cake.
With a little bit of motion.
It's mostly hydrogen. That hydrogen is burning. We also talked in that episode about fusion versus fission. It's actually molecules fusing together, producing radiation, which is a thing that we're not able to replicate. When you burn a thing, you're breaking chemical bonds in order to produce.
Yeah, it's different.
Energy.
It's different than like a fire, like a campfire. Although that's still a pretty good like conceptual model, right? The sun is basically a big ball of fire. It's a reasonable thing to say. It's a big
the idea of radiating energy,
exploding thing.
Something on fire is still radiant energy. Like heat is coming out of it in the same way that the sun is. But the thing to understand about the sun is that it is the only thing. Stars are the only things we know of in the universe, other than I think we've been able to reproduce it on a tiny scale at extreme temperatures with lasers and shit.
We can reproduce it. Like, it's just not energy efficient yet.
Every other process that takes place other than biological reproduction is decomposition.
Yeah,
you're breaking things apart in order to use them or produce energy from them. Or
it's a really interesting point. I mean, chemically in some stuff that isn't entirely true. You get heat from different things happen with different chemical reactions, but it's the only like way of production, energy production in the universe. It's like the way the sun works is like the ultimate known energy production force that we've identified in the universe. It's like the ultimate way that you can
That's why it's the premise of so many science fiction movies, where they're like, "Oh, he discovered the saint
Right, the scene,
Remember that Val
cold
Kilmer
fusion.
movie?
The scene
Remember that Val
cold
Kilmer
fusion.
movie?
The scene
Cold
was
Fusion.
awesome. That was like the height of Val
Which I
Kilmer.
think was a TV show before it was.
It was.
I think so.
Was it good?
No.
The movie was spectacular. He was like
The movie was
just at the edge of being his like weird self enough that he could still pull back, and you were like, he is both Val Kilmer
Still a
and a
badass
secret agent.
agent.
Yeah, so the sun is
So when you say solar system, you mean the sphere of influence of that radiation and that gravitational, like that gravity well, essentially, right?
Yeah, and there's a very specific, well, there are a handful of specific definitions depending on like what realm of science you're talking about, but generally it's interesting how we define that, because the gravity one there, like the sphere of gravitational influence, doesn't really work because that goes forever, right? There's not necessarily, there's like a place where you would fall towards a different body. Like, for instance, when we go towards the moon, at some point you start to fall towards the moon and then you land on the moon as opposed to falling back onto Earth. But I think the general consensus for what constitutes our solar system is where all of these particles coming off of the sun, right? They're firing out. You've got what people hear of as like the solar wind sometimes. It's all these like energized particles, protons, electrons, and stuff firing off from the sun, and they have a real impact on Earth. It's what causes the aurora borealis, those bright, beautiful green and colored lights in the sky at our poles. There's a point out in space, way, way, way past all of our planets, where that solar wind interacts. It hits up against like the galactic solar wind, and all of a sudden it's overpowered. And so like the sun's producing a physical windy force that if you could survive in space and you could like feel the wind, and at some point it stops because it hits the galaxy's general pressure of global wind, and that's kind of considered the end of our solar system.
Is it that it hits that pressure, or that it diffuses so much that it doesn't matter?
There's actually, like, I guess when you start to talk about that, you can start to talk about the other influences of the sun, right? Because the solar wind is actually like physical particles, whereas electromagnetic radiation, like light, is way past. That just keeps going. That doesn't like have the same kind of flow, same kind of like physical flow problems that like a river of wind does.
To constrain the conversation to a manageable territory of things to talk about for
a few hundred astronomical units
for the next 40 minutes. Let's say it's the furthest you could get under the power of a solar sail.
Wait, that could take us really far, though.
I know.
We'll just start traveling out and see how far we get in 40 minutes, maybe.
Just the idea of a solar sail evokes such cool imagery of like airships and steampunk space expeditions.
It's such a beautiful way to get around the universe. I mean, you notice that when you see a sailboat versus like a cigarette boat that's out there with like 500 horsepower engines crushing through gasoline,
muscling its way through some shit. I'm gonna get here. I'm gonna wreck everything in my path.
I'm gonna get here and smoke a carton of cigarettes.
I can get over there, but not until the Earth says it's okay.
There's something really beautiful about that, and I think anyone who like surfs or windsurfs or has sailed, skiing is similar. Like you're moving under like the natural power of the universe. It's not your own body, because even your own body's like you're consuming fuel so you can continue to like run around. But when you're just in a sailboat and you're just cruising, it's so interesting, and it's so dynamic and so organic and so
quiet.
It can be, as long as you're not in a hurricane.
So all semantic nonsense aside,
do.
The solar system that everyone imagined when they saw the title of this podcast,
it's the planets,
generally ends at the debate about Pluto. So we've got the sun, and we've got all these balls of stuff circling the drain toward being sucked into the sun. The closest to being sucked in by the sun is Mercury.
Mercury.
You say that like we teed it up. I'm saying Mercury, like I honestly am not sure what the order of the planets is.
Okay. Why do you need to know the order of the planets? They're kind of
I don't know.
it's kind of the same as like state capitals. Who cares? Why do we have
Because
to
one
memorize
time
that?
in fourth grade, if I didn't know it for a test, I got bad marks.
I'll never forget the state capitals with Mr. Hawley. He was pretty nice about my resistance. He was friendly about it. I think he even worked with me on it. But ultimately, they really wanted me to learn the state capitals. And no, I still don't know them, which is a testament to the fact that I don't need to. They're not useful.
Well, so I think before we do Mercury, we should talk quickly. This sort of relates to that infographic about how we know these things, right? Because we know them in the case of our solar system. It's not just what you described about looking at it, right? Like all the spectroscopy and stuff that we talked about in the other episode about how we understand how we use light to understand what we're seeing at different planets and the composition of atmospheres and stuff like that. We've done all of that stuff with the solar system in a much more granular way because we can see them better.
We've sent
But we've also sent fingers to poke them.
we
There's
put
a
our
little
fingers in the
buggy
pie.
cruising around on Mars right now, and every time they like clear off an inch of soil and look at some new shit, everybody goes, "Woo!" And it's like the fact of how deep their drill can actually drill is almost comical because it's like, yeah, we got a drill there. And you're like, when somebody says a drill, it's like, oh, cool, we're going to go poke some holes in shit. It's like, no, we're going to bore a half inch into the surface of some rock and suck up the dust.
But that's like infinitely deeper than we've ever been on a planet before. So in that context, no, I mean, you make a really good point here. And it's an interesting philosophical distinction as well, because like we talked about in previous episodes, everything we know about most things in the universe that are like off our planet, we know about from looking at electromagnetic radiation, which is light, which is in a way this like, it's a non-reality thing. Like we're all looking around. Everyone who's listening right now is looking at things and they can see light and it allows you to see physical things, but the actual light you can't touch, you can't feel it, you can't really interact with it. I mean, you do.
All you can measure is the extent to which,
but
all you can do is measure the extent to which it bounces off things.
Different, like fantasy thing, right? Whereas the exploration that we've done within our solar system, at least to some extent, we've physically put something there. Like the moon, we've put a person there. People have walked around on it. Mars, we've put little cars on there and you can drive them around.
People have hit golf balls on Mars. I mean, on the moon.
Maybe. I bet Elon Musk is hitting golf balls up there.
I expect someday they'll do it on Mars as well.
He's going to vacation for a couple years.
That seems to be what we do. It's not like because we should, although we should. Like, this is what we got to in the other episode. Like, it just kind of seems to make us happy to like go to Mars and hit golf balls.
Well, there's like an evolutionary component to it. I was listening to something the other day and they were talking about the question they posed, the host of this podcast posed to whoever their guest was why didn't we just, once we found, they were talking about early human civilizations, and they're like, once we found a really sweet place to live, like a really nice lush green valley with a bunch of sweet caves, why didn't we just stay there? And it was a great question.
And I think the default cynical answer is maybe greed, which did drive a lot of this stuff. Maybe. But also there just seem to be weirdos who want to go figure out what we don't know.
Wait, but like, Dad, what's in the valley next door? And Dad's like, don't go over there, man. I mean, our family's lived here for a long time. Like, I need you to help with the wheat. And the son's like, but man,
fuck you, Dad, I'm out of here.
Yeah, screw you. I'm taking my skateboard over to the next valley.
Rebellious phase is built into our genes, right? Like, Probably. It's not even just that. Right?
Yeah,
most people just age out of it.
Most shouldn't.
Fuck
though.
You.
Just learn to control.
I won't do what you tell me.
Look, just wear your helmet, and you can take your skateboard to any valley you want.
Dun, 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 dun. We just have run out of valleys. So anyway, so we've been poking at this stuff, and so in the case of like the solar system, we in a lot of cases we can't necessarily get rovers there, or it's just not worth getting rovers there because we spun a probe around the edge of it and scooped up some atmosphere and went, oh, that'll melt a rover. So we're not, So 9 missions around the sun. Mercury, according to this graphic, we got 2 missions to Mercury. That could be wrong by now.
I don't think we've sent anything else to Mercury. Mercury, I think, is relatively, I mean, what a silly thing for me about to say, but relatively uninteresting. There's not much atmosphere. It's been blown away by the sun. So like what you think of here is like oxygen and nitrogen and clouds and stuff. It was likely that there was a bunch of that on Mercury at some point floating around, but the physical force of the solar wind has blown it away or caused it to chemically like erode and fall to the surface. And so
it's just a chunk of rock. Do we know what?
It's a chunk of rock. It's pretty hot.
It's bigger than Earth.
No, Mercury is real tiny.
Smaller than Earth.
What stats?
But bigger than the moon.
Bigger than the moon. Maybe similar in size. I don't know.
Doesn't matter. Big chunk of rock. What's that chunk of rock made of? Do we know?
Smaller rocks. Let's cruise down here. So unrelated, but I just discovered the most amazing of facts from the Earth Wikipedia page. Flowers evolved later than dinosaurs and mammals. So there were no flowers.
What about ferns?
Ferns are old as shit. Clearly. I don't know. It's a good question.
So Mercury, it's a hunk of rock. We haven't looked at it much because it's boring. Right?
Well, Mercury, I think you can kind of picture it like the way you picture our moon. It's like kind of a static gray crater-filled thing. It doesn't really have an atmosphere anymore. It likely did a long time ago, but its atmosphere has been like physically blown away by the sun. Like it used to maybe have clouds and stuff of different things, maybe not liquid water, maybe liquid water.
Burned off and or bumped away by radiation.
Yep. And it also, it's tiny and old and inactive for the most part, as far as we know, I think. So it's just, it's similar composition to Earth.
I mean, like there's no volcanoes.
There's just nothing happening, which means there's not...
The hunk of rock isn't bubbling.
It's not bubbling. And it's structured similarly to Earth, right? There's like there's a hard, cold crust of rocky surface, and then underneath of it, there's like mantle and melted stuff, maybe. I don't know. I'd have to read through the whole Mercury thing, but the general structure, there's probably a big core of metal at the middle too, which may be solid, maybe it's not. You start to get into another weird place when you try to look inside of planets. Whereas when we look at things that are really far away, we use light. When we look at the inside of planets, we have to use like gravitational fields, and we have to guess at what's in the middle. Even on Earth, we don't really know exactly what's in there. We're guessing based on the forces that are generated by the planet.
Which we talked about in that other episode, right? So there's always going to be this distinction between what we can look at and what we can poke.
We can't poke very far inside the Earth, and we can't poke beyond like an inch on other planets.
Okay, so Mercury, not too big, smaller than the Earth, hunk of rock.
Pretty small, really low gravity.
We looked at it enough to be like, yeah, there's no reason to believe there's anything going on here.
It's not super interesting as a body to go visit, I don't think. We don't like, I mean, we classify interesting as like, are we going to discover something crazy and profound there? Which generally I think is, could something live there? Could something have lived there? And the answer to those is always yes, something could live there, something could have lived there. But Mercury's kind of just dried up, and it's like an old raisin that's been out in the sun all day. It's
also far away. So continue looking at it just because, it's there and we should give it its due relative to every other planet. Like, it's not a thing. You can't be fair with space exploration. It's really hard and really expensive.
We can't share travel equally to each planet.
So as soon as we were like, well, this one's bullshit, we stopped.
Yeah. We're done. We moved on.
So next we got Venus.
Venus starts to
also
be way more interesting.
Also a hunk of rock, but one that we have checked out, according to this graphic, 43 times.
Venus,
it's probably more than that.
Well, Venus is interesting because it starts to share a lot more in common with Earth. For one, it's virtually the same size. So planetary wise, it probably like the same mass and everything too, I think. Similar compositions.
It's relevant talking about size in the context of what that means for their gravitation, like because gravity is a product of mass and how how big, how massive
How big and dense.
a planet is, how big and dense a planet is. Like, if you were born and raised on the moon in lesser gravity, your body would actually be shaped differently because of the forces of the nearest planetary body on your development.
Yeah. You wouldn't be as strong because you wouldn't have
So
to
talking
be.
about the fact that Venus is the same size as us means, like, if life were to spring up and develop on Venus in a track that was similar to Earth, it'd probably look a lot like us.
Got it.
Well, and the cool thing here is that this is the thing. So
Gravity is
gravitational,
almost identical.
yeah. So this is a thing, and we know that because this is a thing you can measure with a probe. When you send a thing out to just circle around a planet, you can tell how much it's getting sucked into that planet.
Well, there's that brings up another interesting point too about what we know with planets. There's another component of understanding that we've layered in, which is like the math of physics. We can look at all the bodies around our solar system, and we know, and we can start to deduce their size, their density, based on their orbits and their orbital periods and their speeds through the sky. And so, not only can we like see them, but we can also start to like generalize things about how big they are and what they might be made of based on what's going on with them. And that's just based on calculation, which is another weird abstract like layering of.
Well, another thing that's also really cool about that piece is it is abstract, but it's also super concrete insofar as we also use that to navigate these places. Like some of these probes that I'm looking at on these graphics, left Earth, circled Venus, whipped back around Earth again to get some more momentum off of our gravity, all just based on calculations. Hey, if we hit it here, it'll whoop and fly back out the other side. Then they looped around Jupiter twice and crashed into the atmosphere. And then we were super stoked about it on social media.
Because we did it right, and they sent pretty pictures, and they were great memes, dank memes, super dank memes, SDMs.
So it's not just right. So you can tell before the probe gets sucked in to. I guess the other thing to talk about is when you're talking about mass and gravity and all that kind of stuff. Like, it's the same as what we were talking about with the sun, right? Every planet is big enough that it also has its little series of things that are circling the drain to eventually get sucked to mash into that planet, which is how they became a planet to begin with over time. But like, the sun is slowly circling the drain. I'm sorry. But the moon is like slowly circling the drain of getting sucked into bashing into the earth. You know, you don't have to worry about it, but that's how gravity works. It's slowly progressing toward being attracted to the earth.
Well,
like
it's interesting in space.
It's not on a time scale you can even wrap your head around without drugs.
Well,
but
you essentially need you need something weird going on to cause these things, right? You need, because essentially there's no concept of friction in space. The moon, once you like send something out there, it just keeps going, right? It doesn't slow down like on Earth. You push your skateboard and it goes 15 feet and then stops because its momentum, its energy was used up, like rubbing across the sidewalk and clattering over cracks and concrete and stuff. But the moon is just out there spinning and spinning. And so something needs to happen that like interrupts that system and causes a change that converts the energy of it spinning around the Earth into its physical movement, which in the Earth moon system, I think mostly is the oceans, because they are like dragged around, and like the moon and the Earth are physically deformed as it spins around. Like the Earth is compressed and expands and compress and expands and compress and expands, and that's part of why it's hot. That's part of why we have tectonic plates. It's part of what causes earthquakes and the tides. And so all of that conversion of this like physical mechanical movement of the moon around the planet is it's converted mathematically, but also in actuality in our universe, it's converted from physical movement to like these things that are happening. And then it changes the balance of the system, and then the moon moves a little bit, and then next year it orbits at a slightly different spot. It's crazy.
And that's happening everywhere, right? So
All of
so when we
everything.
talk about a probe that understands the gravity around a planet, you can get in there and be like, "Oh, we thought it was going to go in this circle, but it went in a slightly tighter circle. So if we adjust our math regarding what we think about gravity and then have a little thruster go a tiny bit, and it pushes back out and then it holds at that orbit, we're like, okay, now we know how much that planet is sucking on this thing to try to pull it in. Like, and that means we know a certain thing about the mass of that planet, at least, because this gravity thing that we've observed and have a lot of math to sort of back up the existence and behavior of seem to solve that problem.
Yeah. Hell yeah. And an interesting thing about our probes and our satellites and our spaceships and whatever, we have to adjust them all the time. They're cruising around like satellites out in space. They have lifetime, they have lifespans because they need to be moved. Things are happening to them. Some of our satellites are low enough that there's still a little bit of atmosphere that's interfering with them. They just orbits decay because of these different interactions between bodies and the forces of gravity and physical changes to their structure and stuff. So we're constantly adjusting.
Quick. How many satellites do we have? How many man-made satellites do we have orbiting the Earth right now?
Man,
because that gives you a sense of the scale on which we're. It's not like you just plop the communication satellite up there and then forget about it. Like there's a team of engineers with Mohawks in a building in Pasadena that wake up every day and check on that satellite.
There are 11 as of this is 2014. There's something like 1,000, a little over 1,000 active satellites, government and private, plus 2,600 that no longer work.
And that's so that's thousands, halfway to 10,000 experiments we've had running for years about the behavior of these orbital dynamics and physics and gravity and all that stuff.
And it's not a constant thing either, right? You can't just throw a tennis ball around the Earth and expect it to spin. Gravity's different everywhere on Earth a little bit, right? There's different structure to the planet. There's different stuff under the crust. They're like on a tiny scale, like Mount Everest, there's a little more gravity there. There's a little more stuff underneath of you. So
all that is
crazy.
Just to support our understanding that people from Venus would probably be our average height.
They'd be pretty similar. They would have to be. They generally hang out in air conditioned units, though. I think because it's pretty hot there. Because of, can you guess why it's so hot there?
Because the greenhouse gases.
Because they drive SUVs. The whole planet. It's all they ever invented. They never realized they could build smaller cars or ride bikes.
And so they just filled their whole fucking planet with methane.
It's just Hummers.
And now it's an oven.
It's just H2s and H1s. They don't even have the H3. It's too small. They don't care.
So if anyone lives there, they live underground. Like we may have to one day.
Venus is similar and interesting. I think we've sent so many probes because there's more complexity. It has a huge atmosphere. And so compared to Venus, it's far enough from the Earth and it's massive enough that it's managed to hold on to some gas that just hangs out around it because the molecules are attracted to the mass of the, well, it also happens to be
and haven't been knocked off by particles.
We still think it's very volcanically active. So the atmosphere is getting blown away because I don't think it has a.
So it's also boiling.
It's boiling and bubbling and exploding and bursting, and I don't think it has a magnetic. Magnetosphere. I don't think it has a magnetic sphere. I don't think it has. It's not generating magnetism around itself like the Earth does, which deflects a lot of the solar wind, which is important for life here. And so its atmosphere, Venus's atmosphere, is getting blown away all the time by the sun, but it's very volcanically active, so it's balancing out. The atmosphere continues to emerge and bubble and boil up from inside the planet, and so it has this tremendous, thick, dense, hot, complex atmosphere with a lot of like organic molecules that there could be interesting things going on there. There's a lot of chemistry, whereas Mercury is just it's really not a lot different than picking up a rock on a hot day on the beach. There's not stuff on it. It doesn't have algae. It doesn't have life. Mercury's like hot, dry, dense. Venus, there's a lot of stuff. It's interesting. They're clouds. They're not necessarily made of water, but it's.
Was I right? Methane?
I think so. Yeah, I think methane's in that area on the chart where it does stuff and turns into clouds and creates different densities and heats and pressures and temperatures, and I don't know what I'm talking about.
Which also past a point is why we're like, meh, let's not send a rover there.
Yeah, well,
Like we're able to observe a whole lot of things by looking at it.
There's some pictures from the surface of I think there's 1 or 2 pictures from probes that have landed on the surface of Venus, which is interesting that it's like we have a billion, everyone's taken pictures of the moon, but there's one human taken photo from the surface of Venus. I think there might just be one. And partly because we haven't sent stuff there, but partly because stuff doesn't work. Like I think we've sent a lot of probes there that have broken or died or burned up in the atmosphere. And
again, all those still provide us data though, because you're like, well, what are the things that could have made that burn up? We know we sent it with rubber and it was made of these things and that things. And the point of failure seemed to be this. So maybe the acidic composition of the atmosphere melted the rubber gasket or something, right? Like
there are lots of pictures of the surface now that I'm looking, but not from a lot of different, there's like a couple landings and we've gotten some photos.
So what we've done is we've landed a static probe on Mercury.
It just hangs out. We certainly don't have little rovers like we do on Mars.
It doesn't drive around. But part of that is because with the static probe, we were like, meh, too hostile here. We can't use it for anything. It's not teaching us anything about our Earth enough that we should, about our hunk of rock.
We've been there a lot,
we should keep poking at it. But yeah, we have been there a lot. It's closer than Mars, right? So
let me see. It's probably fairly similar. I don't know
what the scale on this graphic is, but it looks like it's closer. Basically.
I can't see it in there. It might be closer than Mars.
I don't know. We could look that up. We'll correct it in the show notes if I'm wrong.
We may not.
So that's Mercury. And the next one is the third rock, Earth. We talked about what we do know about our planet a whole bunch in the previous episode. And I feel like we kind of just hit it now in terms of the amount of junk that's circling around it that we put up there, which is technically like in space. Well, let's just do the moon. What do we know about the moon?
Before we leave Venus,
we walked around on the moon.
There's one more interesting component to Venus is that it is just on like the edge, depending on how you define it, of what's called the habitable zone of our solar system, which is this like range of distance from our star, from the sun, where conditions on a planet there could kind of be like Earth, where things could live. And so like where the temperature of the planet, if things were right, would work, and maybe you'd have water, and maybe you'd have certain chemical reactions that are required for the type of life that we've seen on Earth. So Venus is like right there at the beginning. So if you think in geological time, like billions of years, the length of time the planets have been around, Venus could have been very, very, very different. 1 million years ago, 100 million years ago, 3 billion years ago, it could have had a thriving ecosystem. We can't test this. You can't say that as like a scientist. There were dinosaurs on Venus, but stuff could have been there a long time ago. It could have been, and feel like likely was very different.
I feel like what you're telling me is there might be oil on Venus.
That's a sure way to get us to explore. So maybe that's the news we should start spreading. There's oil on Venus. Let's go get it.
There's gold in them thar hills. Okay, so the habitable zone is another interesting thing that I think we've sort of explored before, because we talked about when they discovered the Trappist planets. We talked about it in one of our
It's really
episodes.
cozy in the habitable zone. That's why I like it.
We'll link to that in the show notes as well. But yeah, but it's basically, I mean, even that is just sort of this theoretical thing based on the idea of if you were to reproduce all of Earth's variables, maybe you could grow more humans over a long enough time scale. We definitely can't grow more humans on the moon unless we put them there first.
The moon.
And then they reproduce.
What do we do with the moon?
So the moon used to be a chunk of Earth, right? At least that's
the theory, I think. That there was a
theory right
There was
now.
A collision with something pretty big, like near our size or Mars size or something that was close to our orbit, and collided. We exploded. We had rings. We had basically a reformation of a planet here, and a little moon developed around us, or a very large moon, actually, relatively speaking. The moon is in terms of moon size, relative size to Earth, it's strange. It's not a normal occurrence in our solar system to have a moon so big.
And we also, lending credence to that theory is the fact that we've gone up there 14, 15 times and brought rocks back, and they're kind of made of the same stuff that Earth is made which you wouldn't think would necessarily be the case if it were just sucked into our orbit and then kind of hung out there.
It's
other than it does fall in the same band of sort of gravitational behavior, so it might still be made of the same stuff just by virtue of how close it is to the sun. But it sure seems like we got hit by a comet or something, and it chipped off a chunk of the Earth. And then both of those things squished back into balls.
Yeah, I mean, you can there's this interesting repeating pattern in our universe of things kind of being attracted to each other and forming little disks of things spinning around. And it all emerges from like one place at one point, maybe. But you see that like our moon is interesting in this exploration out through the planets. It's interesting because it happens to also revolve around the sun, but its primary body it revolves around is the Earth. So its revolution around the sun is not a circle. It's this weird pattern, this weird like spirograph pattern as it cruises around the sun. And so there's like a mini Earth solar system. The solar doesn't make sense anymore, but there's like a little mini system around Earth of things spinning, and it's our satellites and it's our moon. And then that little system spins around the sun. And then all the other planets have this stuff too.
So the people that used to think that everything revolved around the Earth, they weren't wrong with regards to the moon.
They weren't wrong.
Everything else, not so much.
And relatively speaking, more philosophically, it's kind of silly to say we rotate around the sun. There is a mathematical framework that makes it simple for us to describe motion that way. But what's the like starting point in our universe? There's not like a thing that we point at as, well, that's the physical center. That's the North Pole of the universe. So it's all a framework thing. And so it seems we've decided in science to kind of take this tack where, well, we'll continue to simplify things because if it's simple, then it must be the way things are. But there isn't a relative point. There's not a reason to say the sun's not circling around the Earth just in a weird way. Like, so in an abstract, like touching on an anti-science perspective, philosophically, it's all the same thing.
We get to the same thing of like, no.
Am I taking Zengineering too far? I'm trying to explore it a little deeper.
No, because it's the same thing we got to with the last time we talked about space, which is like the thing that's exciting and fun about this to me is it's the frontier of like, I think we talked about it earlier, those weirdos that want to explore stuff. Like that's me. I'm excited by the fact that at the bleeding edge of everything we know about space is we don't know a fucking thing.
Here's a great one that I love. If you you can look up some really cool animations of this. We think of the planets as circling around the sun, and because we're used to thinking about it from like an Earth perspective, we think about the sun as being stationary, which the whole planet right now, for the most part, people think about a star that's sitting there stationary and planets rotating around it, which is just as silly as thinking of like the Earth being stationary and things going weirdly around it, because the star is moving within our galaxy, which is then moving within the universe. And so you can look up these animations of our star, kind of how we perceive it moving through the Milky Way. And there's this really cool spiral of the planets. It really gives a sense of how the planets are actually like falling towards the star, because the star leads in this animation. It's moving and the planets are kind of following it as a tail. They're spiraling around it, trying to keep up with it, because the star is ahead and its gravity is pulling these things that are behind it. And when you see, the first time I saw that perspective, that animation, I'm not sure I'd ever really thought about that. And it was so
we'll put it in
from what we can
put it in the show notes for sure.
So much,
but it's weird because you don't, when you think about all the stuff that they teach you in grade school about the solar system, you just at that age you can't get your head around, but also it's hard at any age. It all behaves more like water going down a drain than I think anyone ever wants to really think about, because it makes you feel real small. But like the idea that it just, the sun is just like a molecule in this thing that's all going into a black hole in the middle of this galaxy. And then spaghetti comes out the other side. Like, I don't know, the spaghettification. Like,
I would
And we
prefer
don't know.
pizza come out the other side, but we'll take spaghetti as long as they're meatballs.
so the moon, which we have seen a whole bunch, and I think as explorers and frontiersmen, we're
there.
super excited about.
We've hopped around.
We've hit golf balls, but it's kind of boring.
It is kind
There's
of
no
boring.
atmosphere. It's just a hunk of rock, dust.
We've discovered there's water on its ice cap or on its polar regions, I think, right? Yeah.
But otherwise, nothing else to make us think that there might be life there, or we could live there. I mean, we could live there, but it would be essentially a spaceship on a rock.
It's back
we would have
to oh well, this is
we'd have to take some atmosphere with us. We'd have to take some dirt with us to grow things. There's no
take some dirt. We'd have to till our own garden. We'd have to fertilize our own gardens. The moon is at a
no oil. No oil on the moon.
The moon is at a geological phase that's kind of similar to Mercury, right? If it had atmosphere at some point, which it probably did, it's blown away. It's gone. It's not on it anymore. Its gravity wasn't strong enough to hold it there despite the solar wind. It doesn't have an active core as far as we can tell. There's not active volcanic. They're not active volcanoes. So you're right. It's just like it's like a dried up old tennis ball that's been out it's gray and dry and no life, as far as we can tell.
So the next up is Mars.
Mars.
Which is the most certainly in the general buzz these days, as the moon used to be until we figured out it was pretty boring.
There's so many people that love the moon. They're like, it's not boring, man.
Not boring, you asshole.
Beautiful. There's a man on the moon and it's made of cheese. That's where the cheese comes from. The meatballs come
Mars.
from. Cheese comes
Mars. We've got
almost got a pizza.
A mess of probes we've sent around there. We have one. We have a number operating to support a rover that's driving around there and shooting lasers at stuff to see what it's made of.
Sent a bunch of rovers. There's a new one going up soon, I think.
All kinds of crazy high-res imagery. What do we know about the atmosphere? Not breathable for us, right?
Well, the atmosphere is not breathable for us, right? It's very thin. There's very little atmosphere. And it's interesting when you say breathable as like a description for the atmosphere, because the atmosphere on Earth was not originally breathable. The atmosphere on Earth is only breathable to us because other life evolved before us and changed it and made it into the atmosphere that it is. It produced a lot of oxygen.
Yeah, but I don't want to talk about Gaia hypotheses of symbiosis right now.
Is this not our climate change episode? I got confused.
It's breathable insofar as a sack could suck the gas in and then you could push it back out. You could possibly use it at an intermediate phase.
You could play a saxophone maybe with some slight modifications. You could probably play that Scottish instrument that you play, the bagpipes.
A bagpipe?
Play those there. There's stuff.
You probably need a bigger bag though, so you could push more molecules.
Yeah, you either need a bigger bag or probably like a very, very, very tiny little flute.
What I'm chasing is I can't live there without a helmet in which I brought along a little atmosphere from my planet.
You need like a little plant and a little suit that you're wearing and a little unit to keep you cool and hot
and the reason that this atmosphere. So we're talking about the same dynamics. It's a hunk of rock, and we're trying to figure out if atmosphere has stuck around that rock. What we know so far from all of our testing is not enough that I could survive without a helmet, and not made of things that I could breathe without it screwing up my meat. Like my meat systems that keep me alive. It is that way because we're not really sure. Like, so Mercury and Venus, we know somewhere in their development, here's what happened with atmosphere, right? Mercury is so boring because it's so close to the sun that the sun just blows atmosphere off of it. Mars, because it has thin atmosphere, is not hospitable for us because of radiation problems and like getting cancer. but we're not as clear on why that happened, other than to think about it on like geological timescales, because the Earth sure seems to hold on to some atmosphere, but Mars has been blown off, even though it's farther away from the sun than we are.
I think Mars.
So it's not the reason that it happened to Mercury.
I'm looking
Necessarily?
I'm looking for confirmation. I think Mars has a very weak magnetic field, which indicates potentially, I'm just going off my own intuition, which indicates potentially that its core is cooling, and so it doesn't have the geological activity that it needs to maintain heat and maintain an active surface, and more importantly, the magnetic sphere of influence, the magnetism that forces the solar wind around the planet Earth,
which has to do with the type of rock it's made of and like where it is in its stage of, like you said, cooling. It's all kinds of thermal, geospatial, whatever, concepts. But it has to do with, it's a hunk of rock. It's made of a thing that's not magnetic enough. And so the atmosphere's gotten blown off, and we look at it as a place we could possibly inhabit. It's a better place to live than the moon, potentially.
It's a little more interesting than the moon. I think it's got a little more going on. It's got organic molecules in its atmosphere. The moon essentially has nothing, right? When you picture pictures of people on the moon, it's just blackness, right? The horizon, it's clearly gray moon lit by the sun, or complete darkness on the other side, and then it's black sky, right? You can just see stars brilliantly in the sky. There's nothing in the way. Like on Earth, there's air and there's clouds and stuff. Mars has enough atmosphere that there's structure to it. You can't see stuff. You can't see stars during the day. There's texture to it. There's color to it. There's all kinds of molecules floating around in it. There's cycles. There's chemical cycling on the planet. There's frozen water at its poles that like recedes and whatever the opposite of recedes is. Seasonally proceeds. Pre-seeds, post-seeds, extra seeds. It's got stuff happening that is like, it's like baby Earth stuff happening. So there are ways we can do things there,
or possibly ancient Earth,
or
stuff
very potentially
happening.
Ancient Earth, because it is very much in the habitable zone. So again, Mars could have had all kinds of things happening. And they could have been billions of years ago, and the plates of the planet could have all receded under themselves and gone away, and it's a frozen up crust now of ancient artifacts to be discovered someday deep within.
And here's the part that's interesting about Mars versus Venus that I alluded to before. Mars is a smaller rock than Earth, and so if you were born and raised on Mars, like Earth gravity would be crushing to you.
It would be
in a way that's really hard to even conceptualize. Like imagine if you were walking in a substance that felt like air, but it was more like, it's like walking on the bottom of a pool, right? Like imagine if that's just what it felt like every day.
Hard
you could
to
breathe
around.
it. You were alive because we raised you in oxygen and whatever, but it feels on your body to move like you're underwater. That's how it would be if you were raised on Mars and then moved to the Earth. You'd get out of your spaceship and go, oh, God damn it, I can't even stand up. This planet is so heavy.
It would be like the bottom of
Air
a roller
is so
coaster.
heavy on this planet.
That feeling where your body feels like pressed hard down into the seat, but you'd feel that all day. You would just feel crushed.
Here's a crazy idea. The idea of G-forces that everyone sort of, I feel like, understands, because it's a thing that's cool to talk about with like jet planes and things like that. That's just a relative measure of what you're feeling compared to normal gravity. So like 2 G's is what? Twice the
Earth's
pressure
gravity.
that you feel because of gravity. So that idea of, if you're raised on Mars, your scale for what a G is fucked. Because you're like, no, this is way heavier than a G should be. I feel like I'm at the bottom of a Mars roller coaster. I don't like it here. In that show, The Expanse, they torture Martians by just hanging them on hooks in Earth atmosphere. And otherwise, they like hang out in tanks of water so that they're comfortable.
That sounds great.
You
I would be more comfortable in a tank of water too. I think about that all the time.
That's it. All you have to do is be raised on Mars, and you can hang out in your sack of water that you've dreamed of forever.
Every time I'm surfing, I think, why can't I have a tank in front of my computer that I sit on a surfboard in to work? Be so comfortable.
So here's the thing, man. We failed. Our plan was to do the solar system here, and we're out of time, and all we've talked about are the rocky planets.
Well, we're going to have to do the outer planets then for the next one.
I guess so.
Great.
And the distinction there, right, is
great
that
for
everything past us that we'll cover in our next space planets episode is at a state in its geological formation where it's not a hunk of rock necessarily.
Oh, it gets weirder now because this stuff
is real weird because some of them are just balls of gas.
We talked about the inner planets as they're referred to in like the realm of the solar system, and Mercury, Venus, Earth, Mars. The moon circles Earth. Venus and Mars have moons too. We didn't talk about them. They're not. I don't know that much about them, but they're similar to Earth, right? Three of them happen to be like in or close to the habitable zone. Their structure's similar. We can like go to them and interact with them. When we get to the outer solar system, we got to fly through some weird stuff to get there. And then we get there and you can't do the same thing. There's stuff going on in the middle of Jupiter that's potentially solid, but there's also stuff that we have no idea. We're not sure what's happening. It's so different and it's huge. It's so much bigger. The Earth fits in the red spot on Jupiter. So,
well, and that's what I was talking about before, right? I mean, Cassini's big, glorious end of life mission was to smash into the atmosphere and see what it could figure out.
Mm-hmm.
And they knew that it wasn't going to survive it, but that's just how it goes for that mission. Because past a point, everything we try to put in there melts or disappears.
It just disappears. It burns up. That's the only thing we've tried to put in there, actually, I think.
Well, because they're nothing but atmosphere. They're nothing but the thing that makes space shuttles burn up sometimes.
We want to slow something with a parachute and let it just slowly sink. But it would just get fucked up there too.
Yeah, man. Meat is squishy.
Meat.
So is aluminum.
So yeah.
Comparatively.
Aluminum's just as gentle as meat when you're talking about Jupiter.
So the next one, we'll get into that stuff.
The inner planets.
But thanks for hanging out for this one. Special thanks, as always, to our backers on Patreon who throw us as little as a buck an episode to help lighten the load on us. Servers, things like that. Gotta exist for this thing to exist. But sign up over there and you can come hang out in our Slack workspace where we talk about all this stuff before it becomes an episode, and we dump all the links that we then pick the best ones of to put in the show notes and all that kind of stuff.
Woohoo!
And also thanks to everyone who's rated and reviewed us on iTunes or wherever you listen to podcasts. We suggest Breaker. It's a great app. That really helps us in terms of other people jumping on board with these conversations. Thanks for hanging out. I'm Adam.
I'm Brian. Onward and upwards.
They don't know what I know. They don't know.
Oh, why did you say that with that accent?
Because
Oh, tally-ho!
all explorers have accents, right?